So we are talking about the finite fluid transformation. So we have done the one-dimensional problem, we have done the parabolic problem, and we just started dou u dou t equals dou t by dou x square plus dou t by dou y square, right? Okay, and the boundary conditions are given. Okay, eigenvalue problems are defined. That is d2 psi I, the psi xi by dx square minus lambda. But thing is that this is a straightforward problem. If there is some complicated problem, eigenvalue problem will be coming later on. What I am trying to say that your first step is always Lu phi I equals to J U phi I plus inner product U L star phi. That is always I am saying. This should be your first step. This is your first step. And when you express U equals to summation Ci phi I, this is the final step, right? This two-step process. First step is this, second step is this one, the final step. What eigenfunction it represents? Which eigenfunctions it represents? It is eigenfunction. Is eigenfunction of what? L star. So whatever is actually coming here, that is eigenfunction. So sometimes what should happen, you may not formulate the eigenfunction a priori. What you have to do that? Do this formulation. See whatever is coming L star. Sometimes you can see L star from the problem. Sometimes you will not see. You have to do this mental exercise. Do this mental exercise. What to do mental exercise? After that, only you can say what is phi I, and then you can actually get the phi I. And phi I is the orthonormal eigenfunction. In that case, if you do orthonormal eigenfunction, in that case Ci is nothing but U phi I. Right? That's it. This is the way you evaluate, and entire process is done. Right? So for our current problem, I will not talk about first the eigenfunction. Let's see how the eigenfunction is coming. Okay, that is better. So always I say this is my first step. That's what I always discuss. So I will go by my first step. Dou u dou t, which is dou 2u by dou x square plus dou 2u by dou y square plus f of x. Okay, so this is the way it has been, the equation has been given. And next step will be what? The finite fluid transformation. What is the next step? Pardon? Not self-adjoint. Cannot say self-adjoint. What? I did not say self-adjoint. What is the thing? Next step. See. Huh? No. Again, you are actually saying something. What? Just now what I said? Just now, 5 minutes, not even 2 minutes back. What is that? Lu phi I. So how to do that? So what is the step? Next step, what shall I do? What shall I do next step? What shall I do? That's what I am saying. You know, I can't even say that this layman's word. See, nobody can tell that. What should I do the next step? What inner product? What should I represent inner product? How do I represent inner product? Take no operator. What you are saying operator? You are talking about garbage only. Please don't talk garbage. What we do? I have taught this in 10 plus 2 level. Don't use inner product. See, you came to me yesterday also, and now you are not able to say what to next step. Integral, yes, that's what we always talk. Integral. How many integrals will be there? How many integrals will be there? 2 integrals will be there. 0 to a, 0 to b, dou u dou t, then phi I. What? Phi I will be what? It should be phi I. What will be the solution here? Phi xi phi yi, the phi yj, it will be Cij. This type of problem we have seen in separation of variables. This type of problem we have seen separation of variables because we have got the two basis functions. There will be two basis functions. Each direction will have basis function. If you have three-dimensional problem, we will have three summations. If you have n-dimensional problem, we have n summations. We have seen this kind of problem. And Cij will be what? In that case, Cij will be what? Cij will be double integral limit. You should always say 0 to a, 0 to b, u, not ui, u, phi xi, phi yj, dx, dy, which is nothing but inner product of u phi, you can say some phi, it is actually very difficult to say, so better to write in that form. Okay? Because basically this is nothing but, if you talk in terms of this phi comma xy, phi comma x is the overall eigenfunction, okay, which is nothing but the product of the eigenfunction in x direction and y direction. Okay. We have done similar kind of thing in the separation of variables. Any questions here? Because this problem is going to come in the exam. That's why I am giving so much stress, especially on this. I'll give the exam problem also. Last time I didn't do, this time I give exam problem. I'll see that even after giving the exam problem, nobody will know to solve. That I am going to prove this class. I'll give the exam problem. All problems I'll be giving this time. But what will happen that you won't be able to solve. Okay, this part is clear to all of you. Okay. So, what actually happens? Do you go to phi xi, phi yj, dx, dy. You can write phi xi of function of x, function of y. Okay. Equals to 0, not double integral 0 to a, integral 0 to b, dou to u dou x square, then phi xi x, phi yj y, dx dy, plus integral 0 to a, integral 0 to b, dou to dou y square, phi xi x, phi yj y, dx dy, plus integral 0 to a, integral 0 to b, fxy, phi xi x, phi yj of y, dx. Right? So this, you can see that how we are getting into that. You have to just take the inner product. It's a double inner product. It's nothing but double inner product. You have done this kind of thing in the separation of variables. Nothing but double inner product. Okay, so next, we have not seen the eigenvalue problem so far. We are just doing the first step. We have not seen the eigenvalue. We already know that each direction you have eigenvalue. Eigenfunction problem, x direction, y direction. If you have only one direction, you have only one eigenvalue. If you have three directions, you have got three eigenvalue. Okay. What is that? Very problem?
Sir, attendance sheet.
What?
Attendance sheet.
What?
Attendance sheet.
Attendance sheet. Okay, so next is what we next. So here, if you look at u is the function of x y t, summation x, summation y, ci, which is phi xi x, phi yj of y. So this must be the function of t, right? This must be the function of t. So here, if you look at here, this u is the function of t. These are the function of x and y only. So there is no t dependency. If you take, so in that case you can write it is dou t of u phi xi phi yj dx dx dy. Just like same thing you have done earlier. So your so this I will write this thing as I equals to 2 plus 3 plus 4. First integral is I. First integral is I. What is the first integral? First integral is d dt 0 to a 0 to b u phi x I x phi y j y dx dy. And what is it? What should I say? What is this ddt of? What should I write? What symbol? What symbol it is? What is that? This symbol I defined already. Student. ddt of what? What is that? Cij. ddt of Cij. Second integral, which is 0 to a, 0 to b, dou to u dou x square, phi xi of x, phi yj of y, dx. What we can write? This step 0 to b, 0 to a, dou to u dou x square, phi xi x, phi yj y. Can I write? Separately x is a double integral. We have done in BTech first time mathematics. We have done in BTech first time mathematics. Can I write it? Yes or no? Yes. This part you do integration bypass like ddx of uv. What is that? v du dx equals to ddx of uv minus u dv dx. You find out what is your u, what is your v. This type of things you have done so many times. 0 to b. Okay, next. What should I write here? So many terms will be coming. I will just put more space and put here more space. This will be having j uv term separately and another term will be coming. This is nothing but your operator lu into phi. It is nothing but inner product lu phi, which is nothing but ju phi I l star ul star phi. What is that here? Fill in the blanks. We have done it already. We have done it already. Whatever I am doing, just repetition of earlier what we have done. Repetition of earlier things what we have done. Repetition of earlier things. Yes.
Phi xi dou u dou x a to b.
Dou u dou x.
Phi xi
A
to b.
A to B. A to B. 0 to A. That's what. 0 to A.
Minus u d phi by d.
Minus u.
D phi by d.
Not d. Dou phi x I by dou x. You can say g d also doesn't matter.
0 to
Plus
u dou to phi
0 to A. That's what. Integral u dou to phi xi dou x square. You can put d, no problem. You can put d because you know that phi xi is a function of x only. Then, am I correct? Yes or no? What's the boundary condition? If you look at u at A is what? So now this part is unresolved unless you define the eigenfunction. This will give at this point you can see what is your eigenvalue problem. Why? Because if you say this is your eigenvalue problem, then not you can replace by d2 phi xi by dx square equals to minus lambda xi take phi xi. In that case, this integral is so simple. So this will now, and this leads to definition of eigenfunction. Definition of eigenfunction in h direction. And how to define it? The definition of eigenfunction says d2 phi xi dx square equals to minus lambda xi phi xi. Am I correct? And eigenvalue will have the eigenvalue problem will be having the homogeneous boundary condition. You look at your original problem, boundary operator, which all are display conditions, right? So in that case, your boundary conditions are the same as boundary operator, the homogeneous condition. That means phi xi at x equals to 0 and phi xi at x equals to a equals to 0. So now we can see how I am defining eigenfunction problem by analyzing this one, because this has to be the eigenvalue problem. And what is your phi xi? Phi xi is known. We have done already this kind of problem. What is phi xi? I won't do that. You know the final form. Phi xi. Root 2? No, root 2 by a. 0 to a is there. That's the problem. You always put the value of the formula. It is root 2 by a. Root 2 by a sine I by x by a. That's what the thing is. You arbitrarily, you know the formula, you just put it. That's a very bad thing. That's why I always have to derive it. If you don't derive, you do mistakes. But these are orthonormal functions. These are orthonormal functions. And what actually happens? Your second integral should complete. You want to complete your second integral. What actually happens? 0 to b. What is that? See, this will lead to 0. This will not count, right? Because dou u dou x phi xi at a is 0. Minus dou u dou x phi xi at 0. Where phi xi at 0 also 0. This will not give any kind of impact. Impact will come from here. Okay? And what is that? Which is minus g2 y comma t, right? Am I correct? Then phi xi prime a plus g1 y comma t phi xi prime of 0 phi yj gy. Am I correct? You can see this leads to the integral in the y direction only. Am I correct? Another problem with that, which is eigenvalue problem. And now we can replace d2 phi xi by dxi as minus lambda xi phi xi. And then if you put the lambda minus lambda outside, it will be inner product of u phi xi phi yj dx dy, which is nothing but cij. So we will have what term then? Minus compact form, you write down. You tell me the compact form. What's the compact form? Very cute term will be coming now. In terms of notation. What is that notation? Very cute form will be coming. What is that? Very cute form will be coming. Very cute form. I just told you just now. Very cute form will be coming. Very cute form. Very cute form, what is that? I have just now told it. Lambda xi should not mingle out the symbol. Lambda xi then? Yes, minus lambda xi Cij. Correct. Got it? Minus lambda xi Cij. Right? Yes? You didn't understand, right, Amit? That's what. You don't read the notes. That's the problem. Or which part you didn't understand? Last part. You didn't do it in your notebook, right? What is Cij? How to define Cij? What is Cij? Tell me. What is Cij? What inner product? Am I doing inner product here everywhere? I am doing. See, problem is if I even teach in the kindergarten level, you won't be able to understand. Is the did I mention the inner product anywhere? Every integral. See my situation. Even if I go to 10 plus 2 level, you won't be able to appreciate. You won't be able to understand. You are saying inner product here. This is all inner product. Integrals only. Forget inner product. I don't learn because you don't understand inner product. You tell me what is Cij? Not double integral. The integral 0 to a, 0 to b, then
2 phi xi.
Why you are smiling, sir? Yes. You are booked. Get out. Come here. I am very angry with you. You please stand up. Not you. Here. Blue shirt. Yes. Come here. Take your notebook. You take your notebook, right? And get out of the class. Rest of the class are not able to enter. The first time I am giving this kind of treatment. I am sweating out to teach the class. I don't care if you get double get. Get out immediately. Your roll number is? Your roll number is? CH14 M011. You are not able to enter the class, rest of the class, rest of the course. Go down. If you do something, I put the extreme measure. I have the power to chuck you out of the institute. Yeah, you get out. You just get out. Get out as I am getting angry. I said get out. You are barred, you are from entering the class. Get out. Yes. You out, I said. Okay. 02A, 02B. Next. Yeah. U. What? 5xi of x. 5yj of y. dx dy. Fantastic. You understood that part, right? So now what the second term is coming? Second term is, can you tell me the second part? The term? Second part term you should tell me. What you can see from the board, you tell me, you don't have to do anything. You can't see you're having some eyesight problem. Then I want the second part. See, I am seeing that how much helpless I am. You are actually asking me the questions and you are not able to tell me from the board. Can you read? Can't you read from the board? Did you understand my question? What I am asking? I am asking read from the board. 0 to B. Second part means what? This one I have done. You need to understand this part. Where from this term is coming? I am asking, sir. I am really helpless. See my situation. Did you understand this part? Yeah. Then where from this term is coming? Which term is giving this term? See what the level of yours?
Integral 0 to a d2 pi by dx square.
0 to b, then second term, second part. 0 to b,
Integral u.
0 to b, then
u d2 pi by dx.
only 0 to b, 0 to a will not be there. Sir, better not to ask questions to me. You understood your level, right? Better not to ask me questions because you also get embarrassed. I also get embarrassed. Your friends will get bored, and your friends think that you are stupid also. I don't want that way. The next term,
u d2 pi.
d2 phi dx square dx.
5yj.
Okay, 5yj. Next step. What is this? 0 to b, 0 to a. You just tell half. You won't tell full. If I tell half, how do you feel like? Minus lambda xi, phi xi, phi yj, dx dy. Next step. Minus you can put it here. It should be plus then. Next step. What next step is what? Lambda xi is constant or function? So minus lambda xi 0 to a, 0 to b, 0 to a, u phi xi, phi yj, dx dy. What is that term? C? C? That's what I am telling you. See your level of stupidity, and for that purpose I spent 10 minutes. See your level of stupidity. So please better not to ask any questions because you are not practicing anything at home. That's a problem. So similarly, third term, what it will give? Third term will be what? Can you tell me? I won't give a derivation. Third term. So what I will do that second term, I will write the compact form, which is f1t minus lambda xi ci. third term. And F1t, you know that. This entire thing is F1t. If you want the integral, you get F1t. If you want the integral, you get F1t. Third term. Third term is what? Third term, we have the boundary conditions. Tell me the answer. If you want, you can derive and get me the answer, because this is very similar actually. This is very similar. So there is no point to derive again from my side. There is no point to derive again from my side. There is no point to derive again from my side. What is the third term? What is third term? Integral 0 to a minus or plus? Okay, 0 to a, no problem, you can put minus inside.
Minus h2 of x comma t.
Minus
h2 x comma t.
h2 x comma t
Phi I prime
y yj prime. What is that? A or b? B then
plus h1 x
plus h1 x
of
comma t phi yj prime of 0, right? Phi xi dx, okay, minus. Yeah, so simple. So simple. Did you understand? Okay, good. At least something is going to head. So what is the final form in terms of differential equation? So this I can tell f2t. This entire thing I say f2t. Now all symbols are defined. You tell me the q form of differential equation. You tell me the q form of differential equation. You tell me the q form of differential equation. First term with what? Yes, very good. ddt of Cij equals to f. What is that? f1t minus lambda xi ci. You are very correct. Plus f2t minus lambda yj cij plus. I am saying still 4 now. I am not resolving. Now if you look at, it is like dy dx plus equals plus py equals to q kind of form, right? Integrating factor kind of form you get, right? Same thing you got in the other problem also last time. What is the integrating factor? What is the integrating factor? E to the power? E to the power what? You try to see what is the integrating factor kind of differential equation, which is dy dx plus py equals to q. If it is qy to the power, it is Bernoulli's equation. It is not even Bernoulli, it is very simple form. Dy dx plus py equals to q. What is integrating factor? E to the power lambda xi plus lambda yj into t. What is that? Next step, you multiply integrating factor all through, then you get on q left hand side. What is the left hand side? After multiplying, what is the cube left hand side? You did it last time. What is the cube left hand side? Left hand side is what? Tell me. Cij into e to the power of lambda xi plus lambda yj into t equals to f1t plus f2t plus 4, yes, you are very correct, e to the power lambda xi plus lambda yj into t. Very correct, you are. Thank you. You are understanding very well this up to this part. So now, you this part you know that, you have done so many times. You tell me the answer now, I won't tell you. I want Cij, which is a function of t. What's the answer? If you know Cij, you got the problem solution. Now you tell me what is Cij. Because the solution is u equals to double summation Cij phi xi phi yj. That's all. Phi xi phi yj known. Phi xi phi yj known. Phi xi is root 2 by. So phi yj you can write here. From here you got the phi yj. So phi yj is what? Root 2 by b sin j phi y by b. Am I correct? Phi yj is root 2 by b sin j pi y by b. That's it. So this is also known. So your final solution is summation I equals to 1 to n, summation j equals to 1 to n, Cij phi xi phi yj. That's it. Okay. Integral 0 to t. What is that? I am saying something called q tau e to the power lambda xi plus lambda yj tau minus t. You are very correct. E tau, that is closed, plus c e to the power minus lambda xi plus lambda yj into t. This c can be obtained from the initial condition. What is c? Capital C, which is equals to Cij at t equals to 0, which is 0 to a, 0 to b, u0 xy, phi xi x, phi yj y, dx. Right? Now we can follow my problem, what we have done actually. If you look at my this thing paper, is actually Basak, Bhattacharya Basak 2008, right? 2008 AIC journal. Bhattacharya Basak AICG journal 2008. If any problem, you talk to my TA, Maniratnam can actually help you to download the paper from the lab. So there you can see how I applied the finite field transformation in a heat transfer problem using my paper. Let's say you have solved the problem, right? So now we can see that if we have given any two-dimensional problem, non-homogeneous term is there, time-dependent boundary condition is there, no need to worry about to solve by package or something, we can directly get analytical solution. So you need to avoid using packages. Before ending the finite field transformation, the last part of finite field transformation, I will give the exam problem. So I will announce the exam problem here. The exam problem, question is already there. So I am giving the exam problem. Dou u dou t plus v0 dou u dou x plus v0 dou u dou y goes to grad square u function of xy. Boundary condition ux equals to 1, y t equals to 0, ux y equals to 1, t equals to 0, ux equals to 0, y t equals to 1 minus y, and dou u dou y, x equals to y equals to 0, t x minus 1, and u t equals to 0 for all xy equals to 0. That's the exam problem. How to formulate diagonal problem? Any idea? What will be the eigenvalue problem? This is again two-dimensional. I am not giving three-dimensional problem. Only extra thing I have added these two terms. V0 are constant. No need to mention that. V0s are constant. What is the eigenvalue problem? Any idea? There is how many eigenvalue problems will be there? Two eigenvalue problems. Are you sure? Are you sure? Work it out. You work it out. What will be the first step for this problem? Not in a new phi I x y, which will be combination of phi I x y means, you can say phi I j x y means, which is the combination of phi I x, phi x I, phi y j, right? Which is j u phi I j, sorry, plus inner product u x star phi I j x. We don't know what is else. You cannot guess it. When you put everything, then only you will see what is else. We don't know. I want to have the answer from you. Let's see whether we can give the correct answer. What is the eigenvalue problem? See, locating eigenvalue problem is very important. That should be coming from here. Once you find the eigenvalue problem, other things are very easy. Same straightforward problem. So these are the exam problems. I am giving solution also. I want to see that how many people want to solve the problem even. And I can tell you only 2 to 3 people will be doing it. That's what I want. So last time I didn't give this problem, right? In the announce, I didn't announce.
Green function.
Green's function among the two. This problem, I think this type of problem I have given. Not the exact problem. But I didn't tell that which problem I will be giving. But this time I am giving. So this is the level actually I want to see that. Next time onwards what I will do, I will discuss the answer the problems and ask you to solve the problem. This is next step. This is the way actually I want to proceed my courses. Afterwards what I will do that, after 2-3 years, I will get the answers, you come in the A4 site with the answer and copy in the exam. Okay. See, my point is, I tell you, my principle is very simple. Whatever I have learned, I have learned. Whatever you will be learning is your responsibility. I am not responsible. If I don't teach anything in the class, my knowledge will not reduce. I have gained my knowledge. It is your problem. Right? So now we will be starting Green's function. Last year I took how many classes? 3-4 lectures for Green's function. This year only half of lecture. Because you have to reduce your burden. That's why I told you I want to see the standard of the class. Based on that, I won't even teach next year Green's function. I think maybe last time this time teaching this function, next year onwards Green's function not be the syllabus. So like that, finite transformations will cut down. Okay, and like that I will just cut down 50% of the lecture. 50% of the class I will take, 50% of the class I won't take. Okay, so that will be good for you. So next time we are talking about Green's function. Green's function is also similar to finite transformation, but it's slightly straightforward. Green's function is easier than finite transformation, but only problem is all the time you won't be able to have Green's function. All the time we may not have Green's function. Thus, we cannot use always, but we have to know. That's why I don't give much priorities here. Thus, I don't give much priorities here. Thus, I don't give much priorities here. So, what we do? We have nu equals to. There is some limitations also. Green's function. When you want to solve by Green's function, the limitation is you need to have homogeneous boundary condition. Finite transformation, you have seen that any kind of boundary condition you use, even time dependent also, anything we use peacefully. So finite transformation is more general. That's why I thought in so details. But here, the restrictions are there. First of all, Green's function you won't get all the time. Secondly, it requires homogeneous boundary condition. So I will give 2 boundary conditions. ua equals to 0 and u equals to 0. This type of problem I want to solve by this function. This type of problem I will solve by this function. Okay? Earlier we used phi I, right? And I did LU phi I equals to J U phi I plus U L star phi. Now phi I will not be there. We will be having some function called G, Green's function. We will have some function called G, Green's function, such that we have LUG equals to JUG plus U L star G. Am I correct? LUG, JUG plus U L star G. Right? What is, so now the situation is the L star G is the adjoint problem. L star G is our adjoint problem. One dimensional program block here. Earlier your L star phi I equals to minus lambda phi I. Now the property of Green's function is, it is such that L star G equals to delta x minus. The boundary conditions are such that JUG equals to 0. That means this guy will be going. So what actually happens? How will you get solution? LU equals to F, so inner product FG equals to U delta x minus Z. Am I correct? L star G is delta x minus Z. What is this quantity? So I will come back here. Prior to that, I will talk about something of the delta function. If you don't know delta function, you cannot do Green's function. Do you remember delta function? Did I discuss delta function here in the class? No. Do you know what is delta function? What is that? Is it a function? Is it a function? The first thing I am asking. No. The wrong thing. Delta function is not a function. So delta function is not a function. First thing you have to learn here. AB equals to area, right, of this rectangle. What I am trying to do that, I want to sketch this. I get A prime, I get B prime. Same again. Okay. So then what actually happens? B prime equals to A by A prime. Am I correct? Now what actually happens? If A prime tending to 0, B prime is tending to infinity, right? So what we have found, A prime B prime equals to A, and A prime tending to 0, B prime tending to infinity, still A is a finite quantity. Right? That means what? I am sketching it. And when it is a point, it has to be infinity. It is coming from the formula. Right? B prime is A by A prime. If A prime goes to 0, B prime is infinity now. Something divided by 0. So that means what? Infinity into 0, not infinity to infinity, is going to infinity, going to 0, is a finite quantity. So delta function represents what? to delta function equals what? This is delta function. This is coming from here, right? Initially it was my this thing A. Okay. Already I am getting this straight line. What does it mean? What this hatch area means? This hatch area goes to a straight line, right? That delta function is what? What is that? See the level. Hatch area means what? What is that? Hatch area means what? Somebody told correctly just now. What is that? Hatch area means what? Hatch means area, yes, area of the rectangle. How many times I will give? I one day my dead body will be here. You will be able to learn. This line is what is coming from this hatch type of this. So this line represents what? Area. See, 1000 times I will repeat and then only you will get answer. So delta function is nothing but the area. Is not a function. Delta function is nothing but the area. So what you see here, this is the line. This goes up to infinity, and that is the point x equals to z. So what actually happens? This we represent as delta x minus z dx minus infinity to plus infinity, which we normalize as 1. So this delta x minus z dx, which is an area, and a I am saying as 1. A could be anything, but I am just putting it normalized as 1. So this is the way delta function can be represented. So you can see minus infinity to plus only one point is actually there, as I discussed. Because it reduced to a point, that point is situated at x equal to z. Okay? So minus infinity to plus infinity, delta x minus z dx equals to 1. And that's, so delta function is nothing but area. So now if I multiply fx delta x minus z dx, what you will get? Question. Let's see. Minus infinity to plus infinity. We can also write this as minus x equals to z minus x equals to z plus fx delta x minus z dx, which also you can write using mean value theorem. Fz x equals to z minus x equals to z plus delta x minus z dx, and this is equals to 1, so you get f of z. So if you multiply a function with delta x minus z, you will get the function value at z. This is obtained from, you can write down, this is obtained from mean value theorem. Is obtained from mean value theorem. Is obtained from mean value theorem. So x equals to z minus x equals to z plus fx delta x minus z equals to fz. So you can see that it's coming as fz. This is actually what we are saying that this is my sort of averaging kind of concept. If you want to know what is mean value theorem, it is then on Dewas school or any BTech first year mathematics school. But this is a formula. I don't want to ask you to derive. So this formula is f of z. So from here you can see that u delta x minus z. What will be that? U of z. U of z. So, and z is a dummy variable. So you can write u of x is nothing but integral f gx comma g dx. That's all. So this is a solution. That's all you wanted. You wanted solution, you wanted to have ux. Ux you got an integral.